In my presentation, I'm going to speak about the process of evaluation at the ERC, how grant applications are evaluated. For the ERC, any excellent researcher can apply. They can be any nationality, any age, and they can work in anywhere. However, once they receive a grant, they have to be based in Europe, EU countries, or associated countries. We have three main core funding schemes at the ERC. These are starting grants, consolidated grants, and advanced grants. For starting grants, it's young researchers between 2 and 7 years after their PhD, they can apply. Consolidators, those are researchers from 7 to 12 years after their PhD. And for advanced grants, what ERC is looking at is the last 10 years achievements during the last 10 years of the scientists, because ERC wants to fund the active researchers.
Vaida, I'm really sorry to interrupt. Could you put the slides in the slideshow mode so it's without the screen so everybody can see it? Thank you.
Is it better now?
That's better. Thank you very much.
Sorry. In addition, we have proof of concept. This is a funding scheme for already ERC grant holders and aiming to put the results into the market. As our president mentioned, we also have synergy grant for the last 2 years, and is for 6 years funding scheme, and 2 to 4 principal investigators can participate, which makes different from the core funding schemes, where it's mainly dedicated to individual investigator, and the maximum years is 5 years. You can see the quite generous amount of money which could be asked for and granted if applicant is successful. Now, when you decide to apply, which kind of documents need to be submitted? So there are administrative forms, but for us it's more interesting to speak about scientific forms, which is part B1 and part B2. These both documents have to be submitted together, even though they are evaluated not at the same time. So part B1 contains extended synopsis of 5 pages, curriculum vitae of 2 pages, track record 2 pages. It's a very important document because based on that, evaluation panel decides whether application goes to the next step of evaluation. And then part B2, it's a full, complete proposal evaluated at step 2. And it contains more detailed description of the grant application objectives, methodology, resources. At the ERC, all type of research can be funded, and we have life sciences domain, physical science and engineering, and social science and humanities. In life sciences, we have 9 panels, and physical sciences 11, and social science and humanities 7 panels. So once you decide to apply, you have to choose which panel your proposal is best fit. So here are just the titles of the evaluation panels. To get a more detailed description of which is inside, please have a look at the work program and guide for applicants. At the evaluation, we have two steps. Step 1 and step 2, and in the first one, remotely panel members are evaluating part B1, which is concise synopsis of proposal. Then there is a panel meeting where panel members decide which proposal can go to step 2. For example, imagine a panel receive 100 proposals, and success rate of the proposals is 12 approximately. So 3 times of that amount proposals can go to step 2. So in this case would be 36 proposals would move to the next step of evaluation. So I'm speaking approximately because of course panel members can decide to pass fewer proposals, but they cannot pass more than 3 times of available budget. So in step 2, panel members as well as external reviewers, they look at the full proposal. Again, they have a meeting where they discuss all these proposals. We also have interviews for starting and consolidators grants, and advanced grant interviews are also foreseen. And in this meeting, then it's decided all proposals are ranked and decided which gets funded. Then we also provide very thorough feedback to the applicant so that they can improve the applications in the future if they want to reapply. As it was already briefly mentioned, our evaluation process remains normal practice in peer review journals. We have very high level scientists from all over the world, and each panel has from 12 to 16 panel members and a panel chair working.
Vaida, before you move on, can we just ask you maybe to minimize the screen? We can see the great shapes at the top.
Yeah, just a little Zoom windows with the speakers.
That's okay. You can start. You can close the slides and maybe start again.
No problem.
I think I think in the interest of time, maybe I can continue.
Okay, thank you.
So if you decide to apply, I would highly recommend you to go to the ERC website and look at the ERC already funded projects. You can sort them by funding scheme, call year, domain, or you can use free text search. And then you can see which has been already funded at the ERC and whether your proposal really fits in that. You can also look at the panel members which have been working in the past for the ERC. However, keep in mind that they work every other year, and there is a rotation of panel members. So those who worked 2 years ago not necessarily will be the same working when you apply for the grant. Also, you are not allowed to contact panel members about evaluation. It can have very severe implications. So the only evaluation criteria at the ERC is excellence, which is looked at the point of view of research project and principal investigator. And the panel members are instructed to look at the high-risk, high-end proposals, groundbreaking nature proposals, and not at the incremental research. Scientific approach has to be sound and innovative. In terms of excellence of principal investigator, panel members are looking at intellectual capacity, creativity, and commitment. While you are preparing Part B1, please don't dare to ask yourself, why you are the best person to carry this research out, whether you will be able to work independently and to manage 5-year project with a substantial budget, whether you are competitive, and have you shown your scientific leadership in your CV. And there are rumors that one, in order to be successful at the ERC, one is publication in Nature and Science. However, it's not necessarily true. We have applicants who are successful without having these publications in top science. Well, contrary to what may you think, ERC funds frontier research, but also includes applied research. The budget is distributed among the scientific panels in proportion of the number of applications. So success rate is the same across the panels. And the panel descriptors, which belong to panels I showed earlier, they do not represent ERC scientific priorities. And the host institution is not evaluation criteria. Just few comments about the applicant's profile. The panel members look at the PI's demonstrated ability to conduct groundbreaking research, independent thinking, and whether the applicant has required scientific expertise to successfully execute the project. And which is very important for starters and consolidators, it's scientific independence. And according to our criteria, it's considered that at least one for starters and at least several for consolidated publications without the participation of PhD supervisors are necessary to prove that the applicant has a scientific independence. It's also very important to be able to show the track record of all achievements, invited presentations and conferences, funding, patents, awards, and prizes. And here is, you can find more information in websites. Thank you.
Thank you very much, Vaida, for this insightful presentation. We were going to follow up with Jonas' presentation, that's okay. while Jonas is setting up, we have a question for Professor Bourignon, and I can see he's still here. Would you be okay, Professor Bourignon, to answer one of the questions that's been presented?
Yeah, absolutely. You can do that. I won't be with you very long because I have to speak in Lisbon, but will
absolutely. That's why I thought while you're still here, we have a question for you in the chat, so we're going to ask you. So will EU innovation system cover the current relatively thin ability, especially in smaller member states, to bridge innovation to industry? For example, we're talking about IPI issues, NDAs, technology transfer contracts, and etc.
Well, the ERC is really very open-minded in the sense that we just welcome a proposal by researchers of all forms. So in particular, one thing which I've not been specific about, people could actually be people working in companies. And we do have some examples, not so many, but actually it's not us. It's really that just people don't come with us under this, with this kind of partnership. So now, but you see the key point is that really researchers have to convince the jury that what they propose is really as a great potential. It's really something, really a truly amazing idea. And the idea could be actually something which is quite technological. Most of them are more fundamental research, but it's not, there is no exclusion. And I remember visiting in Sweden, actually at Uppsala University, some ERC grantee, and the first sentence he told me, he said, I'm not a researcher, I'm an engineer. And what I do is to design really tools for researchers. And I never thought I would be funded by ERC. And actually, he had developed several companies developing really instruments. But these instruments were so critical for the scientists that the panels were willing to finance him. And so I think, you see, the key point is really to convince that there is a great potential in what you propose. And I would say the setting is really open. But you have to make the case why it will make a difference. So I think this is not so much, you see, the institutions which make a difference. The institution is not part of the evaluation of ERC. What is the evaluation is the idea, the project, and then of course the panel checks that the person who presents it has a decent chance of making the project go through. And which of course then relies on what the person has been doing. But also one thing we hear, I heard regularly when I was traveling with and meeting as researchers, is a number of them saying, telling me, I submitted my project to my national agency supporting research, and I was turned down because it was too risky. And I submitted to ERC and I was funded. So it's true that we are encouraging the panels to really consider high risk, high gain projects. And that's really what we try to do. The academic community tends to be conservative, so we try to push them out of their comfort zone. And so also this is consistent with your question, that is people who are kind of not the standard profile should not feel shy, but still they have to convince others that what they propose is really, really worth it.
Thank you. And just kind of to lead on as well, which will lead nicely into Jonas' presentation, how would you define excellence? This is one of the most common asked questions.
Of course, it's a very legitimate question because it is used even in the work program of ERC. So actually, the only way we can do that, you see, and that's why it's actually impossible to really give. I'm a mathematician, so I like definitions. Without definitions, I cannot work. But actually, it's very difficult to give a definition for the following reason. That is, there is a huge diversity on the ways in which the research is performed, depending on the disciplines, depending on the object that you are dealing. In some disciplines, individual research makes sense. In some others, it doesn't make any sense. You need a team, you need big instruments, you need infrastructures, and so on. So the way the ERC deals with that is that we give the full power to the panels, because the panels are embedded in the scientific communities, and therefore they know what is relevant. But still for us, and that's one thing which as president I was doing the briefings for the panel members, I repeated all the time, is that for us what is key is really the scientific quality of the project. So for us, this is the reference. And it does mean that we are not caring about impact, for example, but we don't want the impact to be a criteria for selection. Of course, as soon as the projects are funded, the agency, and accompanied by the Scientific Council, of course, make great efforts to really measure the impact, to facilitate the impact, for example, through the proof of concept. And we're actually looking at ways to even enhance these kind of things. So we do care about impact, but we don't want this to be the criteria which is used to make the selection. So for us, selection should be scientific quality. And of course, the definition of scientific quality, it's very difficult to just give one, because again, from one field to the other, what will be the right criteria to determine the quality will not be the same. If you look at particle physics, for example, where many publications are signed by hundreds of people, how do you really determine whether a given person, one person who is a PI, is the right person? So you have to use other tools. Of course, in the social science humanities, for example, we know that, for example, monographies are much more important than articles. We know also in computer science, people prefer as a criteria the proceedings of conferences rather than articles. So I think the way we use and we determine excellence, we just leave it to the panels. That's why the selection of panel members is so important, because we need to have people who are both in their discipline, absolutely recognized, but at the same time broad-minded, as I said in answering your first question.
Thank you very much for all the answers, Professor Bourignon. And that actually leads us very nicely onto Jonas' presentation, how to break through and make sure that that proposal is excellent. Jonas, over to you.
Yeah, hello, everybody. Just before I begin, if I may, I would like to contribute or to complement what the President has just said about excellence. One way of seeking its definition is to go to ancient Greece, and they defined excellence as best fit for a purpose, and that's probably a very good starting point. Best fit for the purpose. Okay, so in my segment, I will attempt to informally sketch the roadmap to producing a competitive ERC proposal. So using the sport analogy, applying for an ERC grant is a competition in high jumping. So with the crossbar being set quite high up. So the ERC's crossbar is a potential of a breakthrough in the proposed research. So only about 10 to 15% of the applicants, they clear this crossbar, and which in the ERC evaluation interface, which you see on the right side, is a cutoff between the funded and rejected proposals. But there is also a little bit more to this evaluation outcome. It is likely that the proposals 5 and 6 were quite similar in their excellence of the proposed science. But what made the difference in favor of number 5 was grantsmanship. And that's the art of clear thinking, persuasive argumentation, and composed writing of a grant proposal. So ERC grantees, they are science composers. Well, of course, grantsmanship will not rescue a bad idea, but the lack of grantsmanship may certainly ruin a good idea. So thus we have learned about two features of a competitive ERC proposal: breakthrough potential and well-argued persuasion or good grantsmanship. So the mainstream commonplace research advances knowledge incrementally by increasing it quantitatively, step by step. And this is all legitimate and laudable. But on the other hand, qualitative breakthroughs in science are sought by exceptional researchers, which are both smart visionaries and composed thinkers. They are credible visionaries. So they walk along those grand frontiers of knowledge and they cast their ideas beyond them. So the passion of such researchers is trailblazing, shifting paradigms, opening bottlenecks, or cutting new ground. So they are risk takers, but if successful, they bring high gains to the knowledge. So the ERC funding is meant for such researchers. And so we have learned about another feature of a competitive ERC proposal, which is credible ambition of reaching beyond the state of the art. Yes, with high risk justified by potential high gain rather than incremental advance. So a promise of expanding knowledge, yes, it can be found in any research grant proposal. But the ERC proposal should seek not just expanding, but also transforming knowledge. And here are examples of incremental and transformative expansion of knowledge. So on the left, so Swiss scientists, yes, they may have indeed plugged the hole of cheese knowledge by showing that hay particles cause holes in cheese, not the proverbial mice or CO2 released by bacteria. And then on the right, there is a discovery of a very different caliber, published in 1740, a couple of centuries ago. So if Newton and Du Châtelet would have competed for the same advanced grants call, Du Châtelet would have ranked higher. And higher because her proposal would aim at transforming knowledge away from Newtonian paradigm in which energy is proportional to velocity, to hypothesizing that energy is proportional to velocity squared. And 2 centuries later, this transformation led to the Einstein's E equals mc squared. And also, just to explain that here shown is the apparatus for collecting experimental data that led Du Châtelet to the discovery by Du Châtelet. It was constructed, this apparatus was constructed by the Dutch scientist Graafsande. He also collected the data. And this machine, it measured the depths of the imprints of balls falling from the ramp at different velocity. It turned out that this depth is proportionate to velocity squared. So the evaluation of grant proposal is putting it on trial. So in a jury panel, a person is innocent, yes, until proven guilty. And in a scientific panel, the proposal is unworthy until proven deserving. So this means that by default, the panelists are constructively skeptical, yes, rather than enthusiastic about the proposal. And so how to outweigh the panel skepticism and prove that your proposal is worthy? So you do that by making your case. So first, you propose an extraordinary, surreal idea. The idea should be risky, but it should not be fiction. It should not be reckless. It should be rooted in both imaginable and factual rationale. And then next, the factual supporting data, also known as preliminary results. Yes, they should mitigate the risk of failure. They should also assure feasibility of a work plan that has to be innovative, has to be well thought through and backed up with alternative strategies. So taken together, these qualities should produce impact, which should be specified and measurable by field, scale, and content. Now, a few remarks on the proposal content and two-step evaluations at the ERC. So the proposal starts with the abstract, which is the most read part of the proposal. It's a business card of the proposal. So it summarizes in a couple hundred words all key elements of the proposed science, so including goal and hypothesis, objectives, research design, and impact. And then the proposal grows into extended synopsis, where all these aspects are clarified with emphasis of breakthrough potential and impact and feasibility. And this part of the proposal, as Vaida mentioned, together with the applicant's CV, is evaluated by the panel in step 1. What is important is that ERC panels are primarily generalists, and that's why the extended synopsis should be generalist oriented. So proposals then selected for step 2, they are evaluated by the panel, but with a crucial specialist written input from external reviewers, specialist input. So that's why the full proposal should be specialist oriented and elaborate and extend on the details of the work plan in particular. So what is important is that all those critical elements of the proposal should be recognizable along its evolution from the abstract to a full proposal, just like you see in this juniper tree, from the sketch to bonsai to a full-size tree in the wild. So once you decided to apply, the first thing that you have to commit to is to put aside distractions and stop multitasking. Because grant writing and multitasking, they just do not blend. And then take your time. In this advice here from one of the sources, take a year of time to think and write, and then to think and write again and again. And save your time, yes, by doing it properly. So a year before the deadline, the idea has to be conceived, discussed. 6 months before the deadline, you should have the first draft on which you will continue working, thinking and working. And then 1 month in advance, you have to prepare the full package for scrutiny by your colleagues. So these are the main points of the road towards writing a proposal. Of course, there could be exceptions, but this timeline is very pertinent, especially for the junior researchers applying for the, let's say, for the starting rounds. So homework, Vaida has already alluded to it. If I were you, I should start with investigating what ERC is already funding, and it will allow you to measure your idea and your track record against those of the ERC winners. And seeing ERC projects may also point to the vacant niches, not as heavily occupied in a particular field, or research paths with less traffic, which means less competition. And there are also other options at your service, such as NCPs and ERC applicants and grantees, ERC panel members that could provide you with a very valuable advice. And finally, there are my colleagues at the ERC Executive Agency, whose first-hand experience and advice, and a lot of such advices are now shared on YouTube in the ERC classes series. So with this, I end by wishing you inspiration, endurance, and good luck in applying for the ERC funding. Thank you.